is as straightforward a problem as you get. It's just taking one relationship that we know, and we plug in the numbers that we're given. If you guys recall, since we said that power is equal to work over time, and work is equal to force times distance over time, we can also just regroup here and say that power is equal to force times velocity. Okay? That we get, that's either an average or it's an instantaneous. Okay? So what we have is we've got force times time, traveling at steady speed, force of area resistance, power necessary. All right, so traveling at a steady speed. Yeah, so in other words, it doesn't matter really what the mass of the rider is, does it? All that matters is that the force of air resistance. All right, so how much power is necessary? Well, look, we have to do a free body diagram on this because we don't know what the force exerted by the motorcycle is, right? We need to know the power of the motorcycle. So if we do a free body diagram, what do we know? What's the thing that stands out here? What's the thing when we're talking about balance of forces? What's the thing that stands out? What do you automatically see? How about this?
Steady speed.
Steady speed.
Constant acceleration.
All right, so, well, acceleration is equal to 0. More importantly, the forces are balanced, right?
Oh.
So if the resistive force, right, the force of air resistance is equal to 2.00 times 10 to the second newtons, this is resistance, that means that's the power that has to be exerted, or the force that has to be exerted by the motorcycle.
But isn't it negative?
Has to be equal to 2.00 times 10 to the second newtons. I've got the arrow to show that one's negative and one's positive.
Okay.
They have to have the same magnitude. Okay? So that's the force exerted by the motorcycle, or the force exerted by the motorcycle as it moves along. Okay. All right, so that's the number that we'll plug in for force, and then we got to multiply it by the velocity, which is 20 meters per second. Okay? So it's a pretty straightforward application of what we've done. All right? So since power is equal to force times velocity, the force is 2.00 times 10 to the second newtons, 3 sig figs, times velocity of 20.0 meters per second. All right, gives us 2 times 20, so power is equal to 40, right? So that would be 4.00 times 10 to the third. What's a newton times a meter? A newton meter, but what's a newton meter? It's a joule. Thank you, Jane. It's a joule, and we divide joules by seconds. What do we get?
Watts.
Somebody said it out there. All right. Watts. All right. So we left our 3 sig figs in place. All right. That was silly.